Hi, greetings. So this is just an overview of our lab of ultra-weak quantum measurements. We have this data acquisition system, which is a 16-bit, 50 megahertz data acquisition system closed in this black box to eliminate RF interference, which has its own Fourier transform software and data acquisition software and time domain. We have this high-frequency microwave 3 gigahertz signal generator from Agilent, which is Keysight now. This is Agilent DSO X3032A, 2-channel 350 MHz oscilloscope, digital storage oscilloscope with its own Fourier analysis and mathematical routines. And then we have a spectrum analyzer from Aronia GmbH, which is closed right now in this aluminum foil. And then we have this one of the best and leading and latest world-class piece of equipment, Stanford Research 2 megahertz DSP lock-in amplifier, which is one of the most sensitive instruments to measure very weak noisy signals. And then we have this Stanford Research ultra-low distortion signal generator for low frequencies, applications up to 350 kilohertz. And then we have this data acquisition system, another workbench for data acquisition, which houses MCC measurement computing DAC, which is 16-bit 2 megahertz sampling rate, 2 million samples per second sampling rate data acquisition device. And then there's just an electronic workbench, which is not in a very good condition right now. So this is where I use my sampling for different devices. This is the actual experiment. What you see here is a Faraday cage, which is a class 1 pure solid copper, 99.99% solid copper Faraday cage, where you have this engine. This is the basic engine for measurement of the experiments that I carry out. This has a low noise amplifier, one of the best low noise amplifiers available in the market today, coupled to an RF detector. And this is for 2 to 4 gigahertz, because the measurement frequencies of interest for my experiments and my studies are 2.75 gigahertz, and this is one of the cavities developed here for this purpose, which is a copper cavity with a center frequency or resonance frequency of 2.75 gigahertz, which corresponds to about 4.12 centimeters radius for this cavity. So we have cavities like these. Right now this is just a demonstration system. We don't have the vacuum chamber installed right now, so this is just an experiment to demonstrate to students where you have a similar cavity, copper cavity, which is coupled to a tunnel diode oscillator detector, which is a special type of